Hi guys, today we are going to solve an amazing problem which is magnets. Okay, so keep focus guys. This problem is very amazing. Firstly, let me tell the question statement. Okay, what the problem statement is saying. Okay, so these are the things. This is the input provided to us. This is the input. Okay, so I will represent these numbers, these alphabets as a matrix. Okay, this is a matrix. This is a matrix, and what this matrix is representing, that in which layout we can put our magnets. So basically we are having a magnet. Okay, we are having so many magnets, and we have to put all those magnets into the same configuration. As you can see, we are having configuration as 5 comma 6. That means 5 represents number of rows, 6 represents number of columns. Okay, so what we have to do, we have to create a array. You have to create an array of size 5 comma 6. So 1 2 3 4 5 and 6. Okay, 1 2 3 4 5. Okay, so we have to create a 5 comma 6 array, character array. Okay, character array. And in this array, what we have to do, we have to put magnets. And we have to put magnets according to these layouts. Let's say this LR, what this LR is representing, that we can put a magnet from left to right. Okay, this LR is represent that we can put our magnet left to right. And as you all know, that magnets have two sides, plus and negative. Okay, magnet have 2 points, plus and negative. So basically we have to put our magnet in plus minus or minus plus configuration. So basically what we can do, we can put here plus minus, or we can put here minus plus. Okay, these are the two configurations in which we can put our magnet. Okay, so let's say here again LR. So LR represents that we have to put our magnet left to right. So okay, what I will do, I will put my magnet plus and then minus. So I put it the magnet. This is the first magnet. This is our first magnet. This is our second magnet. Okay, so what's the problem in this configuration is, you can see this magnet is having plus sign on its right. Okay, and this magnet is having plus sign on its left. So because of this configuration, both of these magnets will repel each other. As you all know that if we put a magnet whose positive end is here, negative end is here. Okay, and if I put one more magnet whose negative end is here, positive end is here, so what will happen? They will repel each other. Repel each other. Okay, so this is the problem, that we cannot put two magnets in such a configuration so that they can repel each other. We cannot put in this configuration. So what we have to do, we have to put minus plus. We are having only one choice, that we have to put our magnet in -1 configuration. Okay, so after this, when I got left right, when I got LR represents left to right. So what I have to do, I have to put minus and plus. This is the only configuration which I can put, because I cannot put plus minus, because magnet 1 and magnet 2 will repel each other. Understood? So this is the case. And one more. Yeah, okay, we have to talk about LR, left to right. We talked about LR. Okay, now what this TB represents, this is the top to bottom layout. Basically TB represents that we have to put our magnet from top to bottom layout. Okay, in this direction. Basically TB represents vertical direction and LR represents horizontal direction. Okay, no problem. So we got TB here. So what TB represents? Top to bottom. So we have to put our magnet in this configuration. Okay. Again, let's see again. Initially I got LR. Okay. So LR represents that I have to put my magnet left to right in horizontal direction. And one more condition, that I cannot put my magnet in such a condition so that they can repel each other. I cannot put. Okay, so LR, and then because let's say I'm putting my magnet in plus minus direction, so this LR cannot be put into minus plus. This is the wrong configuration. Okay, when I got TB, what TB represents, that I have to put my magnet from top to bottom, top to bottom. So let's say I put plus here, minus here. Let's say, okay. So if I, then I will check whether this configuration is stable. Can be this configuration can be taken? No. Why? Because plus plus are repelling each other. This is the first magnet. This is the first magnet. This is the second magnet, and both of the magnets are having plus sign on one end. So they this is the wrong configuration. Okay, this is the wrong configuration. So what is the right configuration? Right configuration is minus and plus. Minus and plus. Okay, this is the right configuration. Okay, now TB, again TB. So again I am having two choices, negative plus or plus minus. Okay, minus plus, plus minus, no problem. So can I take this configuration? Can I take this configuration? No, because negative negative will repel each other. Okay, so what's my only choice? My choice is to take plus minus. This is the right choice. Okay, so this is how I have to place all the magnets into this character array. Okay, this is how I have to place. Now till now the question is little bit hard, but more conditions are applied to this question. We are provided with four more arrays. Okay, this array is called as top. Let me remove this. We are provided with four more arrays. I hope you guys understood this part, what this character array is representing. This array is representing that in which layout we have to put our magnets. Okay, now we are having four more arrays. This is the first array, second array, third array, and fourth array. Okay, so what's the name of this array? Top. This is left, this is right, and this is bottom. Okay, what these arrays are representing? These arrays are representing some numbers which are represented as count of our magnets. So let's see what I said. If I'm talking about top, okay, so top is put it here. Let me remove this, or let me remove this. Okay, we will create a new matrix. So this is our character array. 1, 2, 3, 4, 5, and 6. Okay, 1, 2, 3, 4, and 5. Okay, no problem. Now, what top array is representing? Top array is representing the number of magnets, number of positive sign in vertical column. Okay, what I said, this is 1, minus 1, minus 1, 2, 1, and minus 1. Okay, what this one is representing? This one is representing that how many, oh, not how many, there are one positive sign in column 0. What this one is representing? This one is representing that there are one positive sign in 0th index, because this one is present at 0th index. So I am talking about 0. This one is representing this. Okay. So what this 2 is representing? 2 represents that in this column, I can have two positive signs. Okay, at max 2 positive signs. No problem. What this minus 1 represents? This minus 1 represents that this row, this column can have any number of positive signs. Any number of positive signs. No problem. This one is also representing the same. This minus 1 is also representing the same. And this one, what this one is representing? This one is representing that how many positive signs can 0, 1, 2, 3, 4, fourth column place. Okay, can take place. Okay, no problem. So I talked about top. Now, what this left is represented? This left is representing exactly same, but for the rows. Exactly same thing as top is representing, but for the rows. So basically, this is 2. So 2, 3, minus 1, and minus 1. Okay, what this 2 is representing? 2 represents that how many positive sign. Basically not how many, again and again, basically 2 represents that there can be at most two positive signs in this row, in 0th row. What this 3 represents? 3 represents that this row can hold 3 positive signs at max. No problem. what this right is representing, we talked about top, we talked about left. What this right is representing, this right is representing exactly same thing as left, but the sign will be inverse. Basically, the right array. This is the right array. What this is representing? Minus 1, minus 1, minus 1, 1, and minus 1. So if I talk about minus 1, if I talk about 1, this 1 represents that how many negative signs can be placed in the 0, 1, 2, 3. Third. Okay, so basically this row, if I talk about this row can have at most one number of negative sign. Okay. Basically, if I in general terms, top and right are representing positive sign in column and rows respectively. Understood? If I talk about top, then you have to think in this manner. If I talk about left, you have to think in this manner. Understood? Top will represent vertical, left will represent horizontal, and top and left are represented for positive signs, and bottom and right are representing negative signs. Okay, so I hope you guys understood the question. The question statement is very lengthy and the question is little bit tricky, but I can say that yeah, easy problem. It's an easy problem. If you stay focused, this problem is very easy. No problem. The code is lengthy, but problem is easy. Okay, so you guys understood now. Basically what we have to do, we have to create a character array. We have to put magnets into this array. Magnets can be put into positive and negative. These are the pair. This is a pair which we have to put for one magnet. If I am placing one magnet, that I have to put plus also, minus also. In what layout? Layout will be represented by this character array which we are provided. LR represents that I can put the magnet from left to right. TB represents that I have to put the magnet top to bottom. Okay, and after that we are provided 4 more arrays: top, left, right, and bottom. Top represents that I have to put that number of positive sign in that particular column. Okay, left represents that I can put some particular amount of negative sign in particular row, and right and bottom represent exactly same thing but for negative sign. Okay, so this is the problem statement. Now let's see what is the basically what is the output which we are getting. Okay, this is the output. So let's see how this output is going to be achieved. We don't know now, because this is the output. This is the output, and you have to see what are the basically. Okay, leave it. Where is our input? Yeah. So okay. Now if you see that LR, we are having LR. Okay, as I said, LR will represent as left to right, so I put plus and minus here. Okay, now for this LR I put plus minus. I cannot put negative positive. This plus minus is compulsory. I am not having any other choice. I cannot put this because this will repel each other. Okay, now I got TB. TB represents top to bottom. So I yeah, one more concept. I am having choices. That at every moment I am having choices whether I can put plus minus, or I can put minus plus, or that I will not put anything on that cell. I will remain that cell empty. So in that case I have to put X here, capital X there. Okay, so there are three choices. So if you see that in this we are having TB, top to bottom, that means we have to put our magnet from top to bottom layout. Easy. So in this case what I'm doing, I'm not putting anything. I am just making those cells empty. Okay, that's my choice. Okay, after all, if you see the last conditions, these all conditions should be satisfied for this matrix. We will create so many matrices of this type, but which matrix we have to select? We have to select the matrix which will satisfy the need of all these matrices. Understood? Basically, top matrix is demanding that at 0, 1, 2, at third index, 2 number of positive signs should be there. Okay, let's see. two number of positive sign. Okay, no problem. So what I will do, I will check that 0, 1, 2, 3 at third index. So 0, 1, 2, 3. In this column, you can see one positive sign, okay, and second positive sign. Okay, let's check again. Basically, what this top is represented, top is representing number of positive signs. So here 0, 1, 2, 3. In third index, we are having 2. 2 represents that I can have two number of positive sign. So 1, 2, 3, 4. Yeah, here 1 and 2. So I am having two number of positive sign. That's okay. For left also you can see left represent number of negative sign from left to right, basically in horizontal direction. Okay, so here you can see 3. So in second row there should be 3 positive signs, 1, 2 and 3. Understood? So this matrix will satisfy all the needs of top, left, right and bottom. Oh. Now how we are going to do this? Basically just have abstraction, just focus that what we have to do, what are the choices we have. Okay, so let's say I'm standing on one column. Okay, I'm standing on one column. This is my character array. Okay, and in my main array, basically there are two arrays, two character arrays, two arrays. Okay, basically first array is array, which holds the layout which we have to apply. This holds the layout. Let's say if it is LR, okay. So what I have to do? I have to put a magnet. A magnet consists of positive and negative sign. Okay, so what I have to do? I have to put this magnet into my AR, into my answer array. This is one more array, character, and this is my answer array. Okay, so I have to put a magnet from left to right direction in my answer array. So what are the choices? I'm here. What are the choices? Either I can put plus, minus. First choice. Okay, let's write it again. Basically, what are the choices? I'm present at this point. What are the choices? I can put plus, minus. Okay. Second choice, I can put minus, plus. Okay. After that, what are the choices? I will not put anything. Basically, I will put cross. I will put capital X there. That means this. I will put this. Okay. So these are the three choices at every level. Okay. No problem. So yeah, let's get this there. Let's copy this. Okay. Now if you see that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 and 5. No problem. We are having LR. Firstly, I'm traversing this array. This is a character array. Which is named as AR. Okay. What I will do? I will traverse this array. How I am going to traverse? I am going to traverse this array level wise. Firstly, I will traverse in this direction. Then when I will reach at this point, I will switch my row and I will traverse this column. Okay, this row. Okay, so this is how I am going to traverse. But if you can observe that whenever I am getting L, this is the compulsory case that whenever I will get L, the capital R will be just next to that index. That means if L is present at 0, 0, that this is 100% sure that at 0, 1 R will be present. So I can determine now if I am getting L. So what I have to do? I have to put the magnet in horizontal direction. Or if I am getting T, so what I have to do? In that case, I have to put my magnet in vertical direction. Okay, no problem. So these are the two cases. So let's start traversing. Okay, let's start. Firstly, I will start traversing from this side. So this is 0, 0. So I have started traversing. Now I found L. So what are the choices? The choices are that either I am at 0, 0. Either I can put plus, minus. So basically at 0, 0, I am putting plus, and at 0, 1, I am putting minus. This is the first choice. Okay. What is the second choice? Second choice is that I can put minus, plus. This represents at 0, 0, I am putting minus 1, and at 0, 1 index, I am putting plus. Okay. Now, What is the third choice? Third choice is very easy, that I will not put anything on that index. I will just move to the next index, no problem. So in that case, cross. In this case, cross. Initially in our character array, in this array, all the index values are cross. All the values are cross. Okay, initially we use arrays.fill to put cross in every index. Understood? So if you are deciding that I will not put any magnet on this index, on any index, so basically what you have to do, you have to just switch that index value to the next. So basically, let's say at this point I am deciding that I will not put any magnet on this place. So basically what I will do, I will call the function, I will call the recursion with value column plus 1, with value column plus 1. So basically I left this column, I have not done any operations for this column. Okay, now let's make a tree. Okay, so basically let's say I am at 0 0. Now what are the choices? I got just forgot about LR and TB, just forgot those things, just simply see that what are the choices. Okay, so I'm focusing on what are the choices, because this is the only main code of our problem. This is the only code. Okay, all of the functions are the helper functions to let's say is safe, we will create is safe function, but the main function in which calling is occurring is having two choices, or basically three choices. First choice, that I will put plus minus, this is my first choice. Second choice, minus plus, and third choice, that I will not put anything. So let's say I'm talking about LR. Okay, I'm not discussing about TB, because if you have understood LR, then TB is also easy. Okay, so for LR, let's say I put some positive and negative index on 0 1, on 0 0 and 0 1. Okay, I put plus here, minus here. Now for what index I have to make the next decision? Just give me your answer. Basically what I did, I currently present at 0 0, I put plus here, and at 0 1 I put negative symbol. Okay, now for what index the next decision should be taken? At what index? 0 2. For 0 2 I have to make the next decision, because these two indexes are filled. I have put in some magnet on this indexes. Now for the next index, that is 0 2, I have again three choices, either plus minus, minus plus, or no magnet. Okay, let's see that. Basically I put plus minus here, and I currently I am present on 0 2 index. Now again three choices. What are the choices? Either I can do plus minus, or minus plus, or nothing. Okay, so in this case, if I am putting plus minus here, okay, so just think that initially I got plus minus. Okay, now again I am putting plus minus, so this is the right configuration. This configuration is stable. So on what index I will jump? I will jump on 0 okay. Now just see whether minus plus, can I put this configuration? Initially I am having plus minus. Now the index, the configuration which I got is minus plus. I got this. Can I do this? Can I put this? No, because these two magnets will repel each other. So this configuration is wrong. So we will not move to this condition. Okay, if I am not putting anything, so in that case I will move to 0 3. In that case, what I will do, I will move to 0 3. Okay, now minus 1, choices for minus 1. So if I am putting minus 1, then also I will move to 0 2. If I am not putting anything, in that case I will move to 0 1. Okay, these are the calls. Just analyze what pattern I am following. Basically at every point I am having two choices. If L is present, that currently in ARR row and column, okay, this is equals to L. If the value is equals to L, in that case I am having two choices, whether I can put plus minus or minus. Okay, and after putting these magnets, what I will do, I will move to 0 2, or you can simply say row column plus 2, row column plus 2. My next call will have values row column plus 2, row column plus 2. Okay, now if I got T, if I got capital T. Now in that case, what I have to do? Basically, I have to put, again I am having two choices, plus, minus, minus, plus. So after putting any of this configuration, after choosing any of this configuration, or at what index I have to move? I have to move at row, column, plus 1. Easy. Understood? I have to move to column plus 1. So because I am making the decision for vertical direction. In that case, in LR, okay. So, okay, in LR, I am making choices for a horizontal direction. So in that case, I made a choice for L also, R also. So in after that, what on I have to jump on the next index of R. In that case, I have to jump over next index of R. Okay. Now, if TB is present, okay. So in that case, I have to make decision for row, column, and row plus 1 and column. Okay. In that case, I have to make decision for row, column plus 1. Understood? In that case, okay, wait, yeah, okay. Now in that case, the next recursion call will be of row, column plus 2, and in that case, the next recursion call will be of row, column plus 1. Okay. So let's write the code, because code will give us very good understanding of what we have to do. Okay. So let's start writing our code. Basically, what are the choices? We are provided with row, we are provided with column. Okay. Now we will check whether at current index I am having L or T. These are the two choices. I have to check whether L is present or T is present. No problem. So if array of row and column is equals to L, that means L is present. Else I will check whether row and column is equals to T. Okay, we are having two choices, whether L is present or T is present. No problem. Now you will ask that we are having R also in that matrix. We are having R also, but just imagine that whenever you are getting L, what you are doing, basically you are making two choices. You are making choices for two indexes. You are making, let's say I am having L. Okay, I am having two choices, plus minus, minus plus. For this also, I am making decision for two indexes, 0 0 0 1. For this, I am again making decision for 0 0 and 0 1. So let's say this is L. So this will be R. I said na that whenever you are making decision for L, you have to make decision for R also, because R is just next to L. Every time whenever you are getting L, R will be just next to L. So we made decision for both L and R. That's why we are moving to column plus 2. That means if I am here, the value of column is 0. So I will move to 2. That means I will move to the next index of R. Okay. So in that case, I will make the choices for next values. No problem. Let's say I am making decision for TB. Okay. Let's say TB is present. T and B. Okay. So in that case also, I am having two choices. I got T. So plus minus, minus plus. In that case also, I am making choices, two choices for every index. So basically, let's say I am present at 0 0. So I will make choice for 0 0 and 1 0. In that case also 0 0 1 0. Okay. So understood now. Basically for TB, I will make choices for two indexes, but these indexes are in vertical direction. That's why I am moving to column plus 1. But in case of LR, I am making choices for horizontal direction. That's why I am moving to column plus 2. No problem. Okay. So let's write our code. Basically, if I'm getting L, then I have to do something. If I'm getting R, then I have to do something. Okay. So I will create some if safe function which will tell whether I can put the particular magnet value on that index or not. Okay. Now, firstly, I will check whether is safe. Okay. Is safe to put something. I don't know. I have not created this function, but what this function will return me, whether I can put that. Let's say I'm talking about positive. So this will say whether positive can be put it on that index or not. No problem. So if is safe, in this case, what are the indexes? What are the values I have to pass? I have to pass my answer. Okay, after that, top, left, right, bottom. Okay, and then I have to pass the row column value also, row column and the sign, the character. So let's say I am putting 1 plus here. Okay, I am putting plus here. Basically, what is save function is checking. Okay, let's move again. What is save function is checking? Is save function will check whether I can put, let's say I'm talking about plus. I'm having two choices now, plus minus and minus plus. So I have to make two calls for is save function. Okay, firstly I will check whether I can put plus minus, then I will check whether I can put minus plus. So for plus minus, what I will check whether this plus, let's say for this array, okay, let's say I am putting plus here. I am checking that whether plus is stable or protected on this cell. I am checking now. I am checking whether plus is safe here. So what are the conditions in which plus is not safe here? Just analyze what are the conditions in which plus is not safe. Okay, so conditions can be whether plus can be present here. Yeah, this is the case. Whether plus can be present here or plus can be present here. These are the three cases which we have to check whether plus is present on row -1 and column, whether plus is present at column -1 and row, or whether plus is present at column +1 and row. Okay, these are the three cases which we have to check. Okay, now more conditions, four more conditions. Okay, four more conditions. What are the conditions? Basically, I have to check whether after putting plus, whether I am not exceeding the value of top, left, down and bottom. I have to check now. Let's say the value of top, let's say the top value at this index is 0, where 0 represents that I cannot put plus in this column. Okay, and I am putting plus here. What I am doing, I am putting plus here. So this is the invalid case. This is not safe here. Okay, because the value of top is 0. I cannot put plus in this column. And if I put plus here, this is the wrong case. Okay, so in this case, I have to check for plus. I have to check top and left, because top and left array are taking the decision for plus sign, for plus symbol, and down and bottom, these two arrays are making choices for negative symbol. So if I will check whether the symbol is plus, if the value of symbol is plus, in this case I have to check top and left array. If the value is negative, then I have to check for down and bottom array. Okay, so these are the three conditions, or I can say 6 conditions which I have to check. No problem. So if is safe, answer top, left, right, bottom, row, column, plus. No problem. And is safe. One more is safe function for negative, because I checked that I am putting plus on row column. What is the second choice? I will put minus on row column +1. I am putting plus on row and column. That's okay. At row column +1, I have to put negative. So I will check that also, whether is that safe. So answer top, left, right. Okay, the code is very lengthy, that's why it will take time. Okay, bottom, row, column +1, and then minus. I have to check for minus. No problem. So let's see whether this is correct. Yeah, it's correct. Now, if this is safe, if both of these conditions are safe, that means I can put plus on row column and minus on row column +1. If both of the conditions are same, then what I will do, I will put them. So answer at row column equals to plus. So I put it plus on row column and minus on column +1 minus. Okay, after that I will make the call of solution. Now solution is returning me something that whether I found the solution or not. What this is telling, this is returning me a value which is saying that I found the solution, I found the correct arrangement. So I will check if solution, if you found the solution, if my call, whatever I am calling, if I am getting true, that means I got the solution. So in that case I have to return true. Okay, now what are the parameters which I have to pass in solution? Array, top, left, right, bottom, answer, row, and column plus 2, because this is LR. For LR we have to jump 2, then 2, then 2. Okay, column plus 2. Okay, now if this is returning me true, then I will return true, else I will make the uh, default value. So column should be equals to X and answer column plus 1 should be equals to capital X. Understood? Now exactly same code. This is my first choice. Understood? Now what is my second choice? Second choice, that I will put negative plus here, negative plus, minus plus here. Basically at row column I will put minus, and at row column plus 1 I will put plus. Basically I will change minus and plus, and exactly same here, minus and plus. Understood? Exactly same. Now what I have done till now, I am checking whether currently the value of row column is L. If it is L, then what are the choices? I can put plus minus or minus plus. So I checked whether plus is safe on row column index. If it is safe, then I have to check for minus also. For minus at row column plus 1, no problem. If both of the conditions are true, that means I can put plus here, minus here. I will call for the recursion function, which will return me that whether I found the answer or not. If you found the answer, then simply return. Otherwise, just make the values default values. No problem. Now if I found T means that I have to put my magnet in top to bottom direction. So in this case also, I have to check whether it's safe. Okay, it's safe. Now what this will do, in this case also, I will pass answer, and then top, left, right, bottom, and row, column, and then plus. Exactly same thing, plus. Okay, and is safe. Answer, top, left, right, bottom. After that, row, column, and minus. And here we will write row plus 1, because if we are putting magnet in top to bottom direction, firstly you will put the magnet on row column, after that row plus 1 and same column. Understood? So I made this call. If this is returning me true, that means my magnet is safe. So in that case, what I have to do, I have to put the magnet. So answer row column equals to plus. After that, answer row column equals to minus. Understood? Now at row plus 1, basically row plus 1. Okay, row plus 1. Okay, and after that, exactly same thing. If solution, if this is returning me true, that means I can put my magnet here. So in this case, array, top, left, right, bottom, and answer, row, and column. Wait. Row plus 1. Okay, not row plus 1, column plus 1. Basically, if you are making decision for top bottom, then we have to move to the just next index. So we will move to column plus 1. Okay. After that, if this is returning me true, then I will return true. Otherwise, I will make the default values. Column, and I will write here X, and then answer row plus 1. Column should be equals to X. No problem. Okay, now exactly same call for minus plus. Exactly same thing, minus plus. Okay, just change the symbol. Right here minus, and here plus. Okay, why this is moving? Yeah, right here plus. Okay, just change the symbol. Right here minus, right here plus, and exactly same. Okay, so what we have done till now, basically we have checked for L, we have checked for T. If I'm getting L, so I will put my magnet in left to right direction. If I'm getting T, then I will put my magnet top to bottom direction. No problem. Now we have made two choices. We have made two choices that whether L is present. For L, I made two choices. For T, I made two choices. Now, third choice, which is saying that I will not put any magnet. I will not put any magnet. So this doesn't matter whether I am getting L or T, because let's say if I decided that I will not put any magnet on this index. If I am deciding I will not put any magnet on this index, so this doesn't matter whether you are getting L or T or anything. This doesn't matter because you have decided that you are not going to put magnet. So let's make call that also. Boolean not taken. Solution. Okay, solution. Array, top, left, right, bottom, answer, row, column +1. We will move to the next column, and then we will check whether if this value is returning me true. If this value is returning me true, in that case, what I have to do? I have to simply return true. Otherwise, return false. Okay. Now we have done till now. Basically, what are the functions which are left? Is save function. So basically, we have to complete is save function. Okay. After that, just write the base case also. Just write the base case. Basically, you are traversing in level order. You are traversing from left to right. You are traversing from left to right. So when you have to switch your row, let's say this is my array. This is my array. Okay. So initially we are at 0, 0, 0, 1, 0, 2, 0, 3. Now just imagine the condition in which the value of column is 4. The value of column is 4. That means you are present here. The value of column is 4. So in that case, what you have to do? You have to simply, you have to make column as 0 and increase the value of row. Okay. What this will do? This will move you to this column, to this index, because you are making column as 0. So column is 0. Row plus equals to 1. Initially the value of row is 0. Now row will become 1. So you are present at 1, 0. Understood? Similarly, when you will move here, that means value of row is 1, column is 4. In that case also, you have to make column as 0, row plus equals to 1. So you will move here. After that, again, when value of row is 2, value of column is 4. In that case, you will again do the same thing. Column equals to 0, row equals to 3. Row equals to 3. Okay. So row equals to 3 represents that you have reached, basically row is equals to array.length. If row becomes array.length, in that case, I have to check whether whatever answer I am getting, is that answer valid? Basically, when I moved here, in that case, I have to check whether this matrix is correct or not. Okay. So basically, I'm going to write exact same thing. If column is equals to answer of 0.length, in that case, make column as 0, increase the value of row. After that, I will check whether row is equals to answer.length. If this is the case, in that case, what I have to do? I have to check whether is the answer valid. Whatever answer I am getting is answer valid. Okay, so I will make another function which will check that whatever matrix I am getting, is the whole matrix is valid or not. So I have to pass the valid. I have to pass all of these configurations. So pass this. Okay. If this is returning me true, in that case I have to simply return true. If this is returning me false, in that case I have to return false. No problem. Now, what are the functions which are left? Is answer valid and is safe. So we have to create two functions. Now let's create them. Public static is safe. It will return me boolean value. So boolean is safe. After that, character, answer, int top, int left, int right, int bottom. Okay, these are the parameters now. Let's check again. Answer, top, left, right, bottom, row, column, and symbol. Okay, these are the parameters. Let's write here row, column, and symbol. So character, sign. Okay. Now what I have to check, as I explained, I have to check 4 to 6 things. 4 to 6 things. Basically, I will check whether row minus 1 column is equals to the same sign, or column minus 1 is equals to the same sign, or column plus 1 is equals to the same sign. Basically, if answer of row minus 1 and column, basically I am checking for the upper index. If this is equals to the same, in that case I have to return false. Again, if answer of row column minus 1, if this is equals to sign, in that case also I have to return false. If answer row column plus 1, if this is equals to sign, exactly same, I have to return false. Okay, and for safer side, let's write here if row minus 1 is greater than equals to 0. In that case also you have to check column minus 1 is greater than equals to 0. Okay, because I don't want that we are getting index out of bound array error. So it's less than answer of 0 dot length, enter. Okay, so these are the 3 conditions. Now I have to check whether I can put that symbol in that particular row, in that particular column or not. So basically, for this I have to count the total number of that symbol. Basically, what I mean to say, let's say I'm currently the value of sign is plus. Currently the value of sign is plus. Okay, I have to check whether I am exceeding the total number of values or not. I am exceeding or not. Okay, so basically what I have to do, let's say I'm checking for this position. So I will check whether how many total number of plus are present in vertical direction and in horizontal direction. Understood now? Basically what I have to do, I have to check whether I am not exceeding the limit of plus signs in that particular row and particular column. Understood? So for that, what I have to do, I have to count the total number of plus and in row and column. So what I will do, I have to make two more functions which will provide me the count, of plus or any symbol in that row or column. So what I will do, int row count. Okay, or I can say count in vertical. Okay, count in vertical, and let's take the name of the function as exactly same, count in vertical. Okay, what this will take as argument, answer, sign, and we have to count in vertical direction. So we have to provide the column at which we have to check. So int column, or simply column. Okay, so this will provide me the total number of sign present in that particular column. Okay, now I have to check in row also. So int count in row or in horizontal. Okay, so count in horizontal, answer, sign, and row. Okay, just pass this argument. Now plus sign, if because sign can take two values, plus or minus. If it is plus, then I have to take top and left array. If it is minus, then I have to take bottom and right array, because top and left are holding the answer for plus, and bottom and right are holding the answer for negative. So I will check. Basically, I will check if the sign is positive. If it is positive, then I have to check for top and left. In this case, if it is false, that means it is negative. So in that case, I have to check for bottom and right. No problem. Now, if sign equals to plus, that means I have to check in top and left. So what I will do, basically I will check. Let's say I am present here, and this value, count in vertical. This is holding the value 5. Where 5 represents that there are 5 number of plus in that particular column. So what I will do, I will check whether top of that column. Basically, what this value represents? This value represents that how many total plus that column can hold. This value represents that how many plus can that row can occupy. So basically, if this value is greater than this value, basically if this value, let's say CV, if CV is greater than or equals to top of column, in that case I have to return false. I have to return false because this is the wrong configuration. Why? Because top. Take it very calmly, because let's see here. Yeah, I am checking. Currently I am checking. Okay, so you can see I have not put anything on that index. I have not put anything on that index, and currently I am checking. After calling, I am going to put here. After calling, I am going to put one more plus there. Okay, so just keep this in mind. Now, what I will do, this is my array. Okay, let's say the value of top at this index is 2. Okay, and plus cross. This is the configuration. No problem. Now I call this function. I call is save function. And what this is checking? This is checking whether I can put or not. So this check. I am not talking about this value. I am talking about this. Okay. And one more thing. Yeah. Let's modify this and do it like this. Okay. Now, what I am checking? I am checking for this position. I'm checking for this position, that whether I can put plus here or not. So how I will determine? Basically, this function, this function is returning me the total number of plus present in that particular column. So this function will return me 2. Now what I will do? I will check by the top of column. If top of column, that is 2, this 2. If this 2 is lesser than or equals to this whatever I am returning, whatever let's say this is CV. So CV, if this is the condition, why I am writing here equals to? Why? Because I have not put anything till now. If this function will return me true, then I am going to put one more plus here. After that, this condition will be violated now. So that's why I am checking whether I have reached the maximum limit. If I have reached, then I cannot put anything there. Okay, so I am writing whether CV is greater than equals to top of column. Top of column is 2 and my value is also 2. So if this is the condition, in that case I cannot put anything there. So what I will do, basically I will check if of that column is lesser than equals to count in vertical. If this is the case, simply return false. Exactly same thing for left also. If left of row is less than equals to count in horizontal. Okay, if this is the case, then also simply return false. No problem. Now one more case. I said that this top, left, down and right, this array can hold two type of values. Firstly, -1 and some other integer value. What -1 is representing? That I can put any number of plus or negative here. Okay, I can put any number of plus and negative here. So let's say the value is -1. Okay, let's say the value is -1, or simply here the value is -1. Okay, here the value is -1. This -1 represents that I can put any number of plus here. Then if currently CV is 2, and the value at top column is -1. So in that case also I am checking whether top column is lesser than CV. Yeah, this is the case, this is true, so it will return me false. But what -1 is representing? -1 is saying that I can put any number of plus here. So I have to check one more condition, that top of column should not be equals to -1. Top of column should not be equals to -1. Understood? Why not -1? Because -1 says just put any number of plus here. If it is -1, if it is not -1, in that case I have to check this condition. Okay, exactly same thing for left also. If left of row is not equals to -1, in that case I have to do the same thing. Now exactly same thing for else also. Else part means negative part. In that case also, you have to check for bottom and right, bottom and right, and right here bottom and right here right. Okay, exactly same thing. Now after that, after checking all the conditions, simply return true, that I have checked all the conditions, nothing bad condition is getting satisfied, so I am returning true, that you are safe. Okay, so this is the is safe function. Just check it out, guys. This is very important function. And now what we have created two more function now, count in vertical. So this is very easy function. Basically we have to count the number of plus there. So public static int, this will return me the count, paste it here. After that, what are the values? Answer, sign and column. Character, answer, character, sign and int column. Very easy. I will create a counter initially at 0. Now what I have to check? 4 int I equals to 0, I is less than, I have to move in this direction, in vertical direction. So answer dot length I plus plus. After that I have to check whether that particular index value is equals to that sign or not. So I will check if answer of I column is equals to sign. If this is the case, simply increase the value of counter, and after that return me the counter. Okay, now it's turn for the second function, which will count in horizontal direction. It will count in horizontal direction. Okay, just paste it here. Count in horizontal. Exactly same thing. Here we are getting row. Oh, here I am getting row. After that counter is 0. Answer of 0 dot length, because we have to move in horizontal direction. Answer of row and I, and return count. Okay, so these two functions are also finished. Now we have completed almost 90% of our work, but one function is remained also. Is answer valid? In this case, this is the final case. This is the final case in which we are checking all the conditions, whether all the conditions are getting satisfied or not. That means whether we are equal to top. Basically, if top of, let's say, 3 is equals to 5, then the count of plus in column 3 should be equals to 5, should be exactly equals to 5. Okay, so we have to check these conditions. So let's copy this and let's create this function also. And after this function, this question is completed. So int, or not int, boolean, this will return whether the matrix is perfect or not. Is answer valid? Okay, what are the arguments it is taking? It is taking character array. Okay, answer. After that, it is taking top array, taking left, it is taking right, it is taking bottom, and yeah. Okay, so what we have to do, we have to check in top also, left also, right also, bottom also. We have to check all the arrays. So what we have, firstly I will traverse in top array, top left. After that I will check for left array, left dot length. Okay, so if I am checking in top array, so what top array is including? Top array is saying that what is the limit of holding plus sign. Basically, if top of 2 is 3, then this is representing that at second column I need total of 3 plus symbols. What top of let's move here. Okay, top of 2 is 3. What this is representing, that at second column I need a total of 3 plus symbols. This is what top of 2 is representing. So what I will do, I will check whether int row count, and what I will do, or you can simply count in vertical. Exactly same thing. Count in vertical. Okay, after that what I have to do, I have to pass answer, sign and column. Answer sign is plus because top is holding the values for plus, and pass here I. If top of I is not equals to count in vertical, if this is the case, if the case, simply return false. Okay, for left, exactly same code, just change the values, count in horizontal, horizontal. Okay, horizontal. Now count in again, just copy this and paste this. Okay, here also I'm going to pass answer plus I. If left of I is not equals to count in horizontal, then simply return false, and just copy these two cases and paste for left. Okay, for right and bottom also, right and bottom. Understood now? Very lengthy code, but yeah, this is the correct way. Okay, count in vertical for right. I have to check for count in horizontal. This is the case. Okay, so just paste this. Okay, right dot length, count in horizontal. Answer, yeah, this is good. And right here, right. After that, exactly same. Bottom dot length, yeah, this is correct. Count in vertical, count in vertical. Okay, here also count in vertical, and answer plus I. If bottom of I is not equals to count in vertical, just copy this and paste. If this is the case, then also return false, and after all the hard work, simply return true. I don't need anything, simply return true. Okay, so let's dare to run this because we are getting so many errors. Okay, so 111, let's see. 111, yeah, is safe. So whoa, safe function, and yeah, what's the difficulty? This is the case. Okay, so we are getting error in this line because of parenthesis. So yeah, we have to put one more parenthesis here. Okay, so exactly same thing here, just one more parenthesis here also. Okay, this is correct, and this is also correct. Okay, no problem. Let's run this again. Okay, we will get compilation, but this is the code. Yeah, this is the code. Okay, this is the code. Basically, what we are doing, we are checking that we are having L or T. If it is L, then we are having two choices: plus minus, minus plus. For plus minus, I am having I have to check whether plus is safe at that index, minus is safe at that index. If both are safe, then I will put plus minus on their respective index. I will call the recursion function for further indexes. Same for minus plus. After that, if I'm getting t, then again I will check for minus plus, minus, and then I have written the is safe function. For is safe, I have to check three or four conditions, where I will check that whether same symbol is present on upper index, right index, left index. If it is the case, return false. After that, what is the case? I have to check whether I am not exceeding the total number of count of that symbol in that particular array. Let's say if it is plus, then I will check for top and left. If it is minus, I will check for left and I will check for right and bottom. So for this, I created two more functions which are returning me the count of that particular symbol in that row and column. Okay, after that I created a final function which is answer valid, which is checking that whether the final configuration which I got is valid or not. Okay, this is the whole concept of this question. So now we have the only task is to remove all the errors. Okay, we will get error because the code is very lengthy. Now let's see. Cannot find symbol top of column. Okay, so this is the case. Top of column. Where is top? Top column is not equal to -1. Top column count in vertical. Whoa. Count in vertical. Okay, let's copy this. Paste it here. Maybe the name of function and variable is exactly same. This is provided. No. left here, horizontal, right here, horizontal. Okay, 32, no problem. Count in, paste it here, and horizontal. Okay, 103, no problem. 103 is answer valid. Answer top, left, right, bottom. Okay, what's the problem? Cannot find symbol is answer valid. Whoa. So we have created the function now. The name of function different. Is answer valid. Is okay. Is answer valid. Okay. No problem. Is answer valid. No problem. Just run this code again. Okay. We are getting wrong answer. Let's see what's the problem. Basically, okay. So guys, I found the error. Basically, we are not calling our function. Okay, so I forgot to write to call the function. Basically, we have to create our answer array, new char, which is of size m and n. Okay. After that, what we have to do? We have to fill this character array with x, capital X. So 4 int I equals to 0, I is less than m, I plus plus. 4 int j equals to 0, j is less than n, j plus plus. After that, I have to put capital X on every index. I, j should be equals to capital X. Okay. After that, I have to call the function. If my function is returning me true, in that case, I have to print the configuration. After that, else I don't have to do anything. So if solution of solution, and here array left, top, left, right, bottom. After that, answer and 0, 0. Initially the value of row and column is 0. If this is returning me true, in that case I have to print my answer. Else I have to simply print system.out.println no solution. Easy, very easy. Okay, now let's run this code. Okay, we are getting a publisher at 237. Okay, answer equals to new char. Okay, what's this? What's the problem? Variable answer is already defined. Okay, so this is already defined here. So we don't need this. We have to simply call our function. Okay, now our code is accepted. Let's submit it. So I hope I have given the quick overview also. So I hope you guys understood what we are doing, how we are proceeding this question. This question is little bit tricky, but I will suggest you to do this question on your own. Okay, just practice this question to do on your own, and you will learn a lot of new concepts with this question. Okay, so this is all about this video. I hope you guys understood. We will meet in the next video. Till then, bye.